So for today, we're just going to focus on reflections. So reflections is what we're focusing on. So throughout the chapter, the 4 transformations, we'll focus on one each day. And today we're just focusing on reflection. Okay, so what is a reflection? A reflection is when you flip a shape over a line or axis. So for example, a dotted line right here, if you have a shape like a triangle, and you just flip it over the line like this. It's like a mirror image. When a figure has been reflected, it will be a mirror image of itself. Okay, so here we're going to look at some of the different reflections you'll see. A lot of these just like repeat themselves. Before we start reflecting whole shapes, we're going to start by reflecting points to build the concepts. So first one, we're going to be reflecting this point over the x-axis. I don't know why this little line didn't print right here, but there's a line here too. So reflecting over the x-axis, they trace the x-axis for us. Actually, we're going to go through and look at all the reflection lines, and just if you have a highlighter, you can highlight it. This one, we're going to reflect A over the line y equals x. The line y equals x is a diagonal, and it has a positive slope. So it just goes right through the origin. It has a slope of 1, up 1 over 1, like that. So that is the line y equals x. Then here, it says the line x equals 4. So you just find x equals 4 right here and draw a line through it. And then for this one, the y-axis right here. So we're going to reflect that point over the y-axis. This one, kind of like the hardest one, but it's the one that they love to like challenge you with on testing. Y equals negative x. That is a diagonal through the origin. It has a negative slope. So it's going down and to the right. And the slope is just down 1 over 1, down 1 over 1. And then a line at y equals negative 3. You find y equals negative 3, which would be right here. Draw a line, and that's the line of reflection there. Okay, so for this point, reflecting it over the x-axis, all we're going to do is we're going to look at how far that point is away from the line of reflection. So this is 1, 2 units away, 1, 2. So we'll just count 1, 2 units below, and that is A prime. That was on the last page. It's the second. It's the image after the transformation. Okay, so another thing we're going to look at is what happens to the coordinates. So for A, the original, it is at 2, 2. And then A prime is at 2, negative 2. So the x is staying the same, and then the y is changing sign like this. So we have 2, 2. X stays the same, the y changes sign. So depending on the reflection, there's a rule like this where you could just use the coordinates to figure it out. I also have this chart up here for your reference as well. Okay, the next one, reflecting over the line y equals x. We highlighted the line. We're just going to make this point the same distance from the line on the other side. So this is one diagonal away, so we can make it one diagonal away on the other side, and we get A prime right here. And then looking at the coordinates, A is at 1, negative 1, and then A prime is at negative 1, 1. So essentially, the x and y switched places here. So xy became yx. Okay, then for this one, just reflecting that point over. It's 1 unit away from the line, so we put it 1 unit on the other side, A prime. Okay, there's no rule for that because it depends on where that line is. And then this one here reflecting over the y-axis, it's 1 unit away, so we put it 1 unit away over here, A prime. The original A is at -1, 3, and then A prime is at 1, 3. So xy becomes -xy, -1, 3 becomes +1, 3, like opposite side. Okay, and then reflecting this point over, it is 1 diagonal away from the line, so we put it 1 diagonal away on the other side. We get A prime right here. And for the coordinate rule, xy becomes -y, -x. Let's see how that looks here. So we got -2, 0, and A prime is at 0, 2. So starting -2, 0. Then y goes here and it's negative. However, 0 can't be negative, so it just stays. And then this turns opposite sign. And that's what we got here too.
Wait, why do you take a
Because x becomes like -x or opposite sign. So that's why I did that. So this here, which is x, opposite sign is here. Okay. And then for this one, reflecting this point A prime right here. No rule because it depends on where that line is. And then we're going to flip to the next page where we start like looking at whole shapes. Okay, so here we're looking at whole shapes. It's the same thing we did on the last page, just now we have more points to reflect. This first set of examples, it says write the rule for each reflection. So we look at these two shapes, like where is it reflected? It's reflected right here, which is the x-axis. So the rule is reflect over x-axis. And in terms of the coordinate rule, I know this didn't print too well, so this would be, this is B, and then this is B prime here. So point B is at -3, 2. B prime is at -3, -2. So x, y became, the x stayed the same, and the y changed signs. Which is the same thing that we have right here. X stays the same, y changes sign. And then B, we have to figure out what line this is reflected over. This is reflected over a diagonal with positive slope. This line right here is the line y equals x. Reflect over y equals x. And then the rule for that, you could figure it out using the coordinates, or you could just use the rule. So x, y becomes y, x. Well, this line is always y equals x. It's through the origin and it has a slope of 1. Up 1 over 1, up 1 over 1. And then the next one, the line this is reflected over is right here. So I just have to identify what that line is. And it's at x equals 2 right here. So reflect over the line x equals 2. Okay, and then this part, it says reflect the figure over like a certain line, and we're actually doing the reflecting. So we have to determine what this line is. Y equals 1. Y equals 1 is right here. So this must be the line of reflection. And so I'm going to reflect each one of these points over the line. So like E is 1 unit away, so I put it up here, E prime. D is 2 units away, so I just count up to D prime. And then this says F right here. And it's 1, 2, 3 units, so 1, 2, 3, and I put F prime, and then just connect my dots. And so there's really good practice with Alex, as you can imagine, where you're actually graphing the reflection here. So then reflect the figure over the line y equals x. So that is that same line that we saw here. And it's just like a diagonal through the origin. So I'm going to use the straight edge so I can get it perfect-ish. So there's our line y equals x. Okay, and then reflecting these points over, I'm going to count the diagonals. So from C to this line is 1 diagonal. So I can put C prime like 1 diagonal away. So here is C prime. And then from B to this line, 1 diagonal, 2 diagonal, 3 diagonal. So I do 1, 2, 3, and put B prime right here. And then A, same thing, just count the diagonals. 1, 2, 2.5 to the line. So I can count half, 1, 2, and A prime. And then connect my dots. Okay, nothing new. Now we're just practicing that down here. So graph each transformation and it tells you what to reflect over. So reflect this over the line x equals -1. So determine where x equals -1. Draw a line. And then reflect the shape over it. So B right here is 1 unit away. So B prime would be right here. 2 units this way. A prime. Connect your dots. B reflect over the y-axis. So just identify the y-axis right here. And then reflect the points over the same distance. So we get M prime, 1 unit away. L is 1, 2, 3, 4. So 1, 2, 3, 4, L prime. N is 1, 2, 3, 1, 2, 3, N prime. And connect. Okay, C, reflect over the line y equals 4. So I find y equals 4 right here. So this is like worst case scenario, like the hardest it could get, where the shape is like on the line of reflection. For this, you just have to trust the process. You're going to just use the same process. If point y is 1 above, just put it 1 below, y prime. If z is 1 below, put it 1 above on the other side of the line and just reflect each point and trust the process. X is on the line, so its reflection for x prime would just be on the line. And then connect your dots, and you're good. Okay, for D here, reflect over x equals 3. X equals 3 is right here. So I'm going to draw a line of reflection. Then each one of these points I'll reflect over that line. So A is just 1 away, A prime, B is 2 away, B prime. There we go. For E, reflect over the line y equals negative x. This is the one that they love that's kind of tricky. It's just diagonal through the origin with a negative slope. Okay. And then just reflect each point over on the other side. So this is half of a diagonal away, so I put L1 on the other side of that. And then K, I'm going to count the diagonals to this line. So 1, 2, 3.5. So half, 1, 2, 3, and K will be right here. K prime. And last but not least, reflect over the x-axis right here. 1, 2, 3, 1, 2, 3, L prime. This is an M. 1, 2, 3, M prime. Then O and N just stay on the line. There's one more type of problem that might show up that I want to go over, and it is how many lines of symmetry does a regular octagon have? How many lines of symmetry does a regular octagon have? Okay, so a line of symmetry would be like a line of reflection within the shape. So regular octagon, all the sides and all the angles are the same. For an octagon, it has 8 sides, so therefore there would be 8 lines of symmetry. So you just use the number of sides. So for example, a square with 4 equal sides would have 4 lines of symmetry. And so whatever number of sides it has, that's the number of lines of symmetry. Okay, so I'm going to have you start your homework now. If you finish your homework, then jump on to Alex and get that started as well. And if you have questions, please let me know. There's also graph paper up here if you need it.